Hi students, today I am explaining you one small concept that is isomerism. In the isomerism, one of the important area, geometrical isomerism, it is concerned in stereoisomerism. It is very important topic. A small explanation I will give you. You know that already what is the isomerism definition? Isomerism definition means molecular formula is same but structural arrangement is different. That is called as isomerism. So isomerism, different isomerisms are there. As per isomerism organic chemistry point of view, two types isomerism: structural isomerism and stereoisomerism. Stereoisomerism, two types: configurational isomerism and conformational isomerism. In the configurational isomerism, one of the isomerism is geometrical isomerism. It is very important area in the isomerism, geometrical isomerism. That is one small explanation. On that, one small explanation I will give you. What is geometrical isomerism? Stereoisomerism is what? First of all, stereoisomerism means is a spatial arrangement of atoms. Spatial arrangement of atoms or group of atoms around the double bond. Stereoisomerism, simply. As per the alkenes, I am saying, as per the alkenes. This is the alkene. This molecule also alkene. Look at this molecule. This is the alkene. Double bond is present between the carbon atoms. The blue colors are double bond carbons. Here the something groups are connected here. Something group. Here the something groups are connected. So spatial arrangement of atoms or group of atoms around the double bond is known as geometrical isomerism. It is concerned in stereoisomerism. So what is geometrical isomerism? Geometry means shape, arrangement. Spatial arrangement of group of atoms or atoms around the double bond. Around the double bond. This is the double bond. Around this double bond, the group of atoms are arranged, spatial arrangement. But one point here, observed here, stereoisomerism is a stereoisomerism, concerned in the stereoisomerism. Hold here, this carbon hold, and it is possible to rotate this freely rotation. Free rotation is not possible because of restricted rotation of double bond. Double bond is restricted. So CC rotation is not possible in the case of alkenes because of the double bond is present. So here geometrical isomerism specifically observed in the restricted rotations of molecules. That means CC double bond cases. Geometrical isomerism. First of all, restricted rotation is compulsory in the case of alkenes. Now observe here, geometrical isomerism, different categories are there. Cis-Trans, E-Z, Sin and T. They are different molecules. Cis-Trans we are observing now. Cis-Trans. What is the meaning of the cis? What is the meaning of the trans? Cis means this is the double bond. Here the double bond. To this double bond, these groups are present here. To this double bond, these groups are present here. As per the view, how the molecule is appears look like, this is above, this one is the below. Observed here, in the above, the two groups are same plane, above the plane. The two groups are below the plane. Now observed here, this molecule. The same color balls are existing in the above the plane, and here the same colors balls are existing in the below the plane. So to the double bond, around the double bond, identical atoms, similar atoms or similar groups present on same side, that is called as cis. Identical atoms or group of atoms present on same side, that is called as cis. For suppose this molecule. And now one more point, same side is okay. But here, this carbon having, for suppose this is considered as chlorine, Cl. This carbon having chlorine. The chlorine present on adjacent carbon atoms, not same carbon atoms, compulsory. If it is present on adjacent carbon atoms on same side, that is called as cis. This is called as cis, similar groups, same side, adjacent carbon atoms, not same carbon atoms. Here, the same carbon having one carbon having the similar group, one carbon having the similar group. This is not showing the geometry cis-trans isomerism, this molecule, because of similar groups are present on same carbon. What is needed? Similar groups on adjacent carbon atom, same side is present, that is cis. Now here cis. For suppose I am changing the positions of these positions here. Now observe here, similar groups how they are existing in this arrangement. This is above the plane, this one is below the plane. Both are oppositely existing, that is called as trans. Cis-trans are Latin words. Cis means same side, trans means opposite side. So this is the cis molecule, this is the trans molecule, because of similar groups are existing opposite side to each other, opposite side. So this is cis-trans. So cis-trans observed in the alkene cases. This is simple alkene. Okay, in the case of poly, double bonds are present in the molecule. If the molecule is large molecule, more number of double bonds are present. Simply look at this molecule. Adjacent carbon atoms. Here the double bond, here the double bond, here also double bond is present. This kind of alkenes are called as polyalkenes. First of all, polyalkene, poly means more number of double bonds are present. But alkenes are different types of alkenes are there. Isolated alkenes, cumulative alkenes, and conjugated alkenes. Different types of alkenes are there. This comes under in the cumulative alkene. Cumulative means double bonds are present on adjacently. Adjacent carbon, adjacent carbon, adjacent carbon. Cumulative alkene. What is conjugated alkene? What is isolated alkene? I will give the clarity later. This is the cumulative alkene. Observe here. Before that, in this molecule, now observe here, these groups present on the same plane. For geometrical isomerism, the groups should be same plane. Now take this molecule. Observe here, this way. Observe here. For suppose this is vertical arrangement. These two groups are existing in the vertical arrangement. This double bond is existing horizontally. Now this double bond is existing vertically. This double bond is existing horizontally. Now these groups, end groups are existing vertically. How many double bonds are present? Odd number of double bonds are present. 3 double bonds are present. Odd number of double bonds are present. End groups are existing in the same plane. Now observe here, same plane. Here the same plane. This yellow colored atom and this yellow colored atom are group of atoms existing in the same plane. Above the plane. These two are existing in the below the plane. So this comes under in the which arrangement? Cis arrangement. Comes under in cis arrangement. If in case because of same plane and similar groups are present same side, change the positions, this ball here and this ball here, that is comes under in trans. So this is odd number. Now take it as a other alkene, that is even number of double bonds. Even number of double bonds means this is double bond, this is double bond. 2 double bonds are present, even number. 2, 4, 6, like that, even number. Now observe here, this molecule shows the geometrical isomerism. No. Reason? Because of end groups are present different plane, not in the same plane, not on the same plane. Here, this is vertically arrangement, horizontal arrangement. Vertical arrangement, horizontal arrangement. The arrangement of these groups existing in the different plane, but compulsory the groups should be same plane, groups should be end groups. Now here this is one plane, this is another plane. Geometrical isomerism is not possible. For showing geometrical isomerism, what is needed? Groups should be same plane is needed, same plane. So this molecule having even number of double bonds, this is not showing the geometrical isomerism. So geometrical isomerism observed in the alkenes, simple alkenes, cumulative alkenes, isolated alkenes and conjugated alkene also. Those are I will explain you later.